So, in this video I'm just going to briefly give some instructions and tips regarding the assignment going along with this week. So originally, this was what I gave as the assignment was a 15-page PDF. That I thought was too long. I was able to get rid of 4 of the pages. That was, for a variety of reasons, still too long for me. So I ended up making it to where it printed in such a way that each page had 2 pages of the original PDF printed on it, so it's sort of sideways. So that's why it looks the way it does. Now, the first things in it are questions 6 and 7. You do not have to do them. I would have cut them out if I could, but they were on a page with something important in it. It also uses the terminology of explorers. Explorers are kind of like questions, but I guess they're like questions that they think that other questions are going to be built off of, so they call them something different than questions. I don't know. It's a little weird, but so that's if you see something referring to like, oh, look at Explore 2, that's one of the tables you made. Now, Explore 2 involves a table with 3 columns. You do not need to fill out the 3rd column of Explore 2. I don't know why they even put it in. You only need to fill out the 2nd column. Explore 3, however, is very similar, and you will need to fill out all 3 columns there. Now, we're going to look. This assignment involves looking at actual spectra, but they're a little tough to read, so I'm going to give some guidance here. So, there are 7 stars, and they each have a spectra, like this. Now, this top thing is the overall spectra. The x-axis has the wavelength with an A, right? You might be able to see. That means angstroms. It's a very small unit of length, something like 1 times 10 to the minus 10 meters, something like that. So that's like the color of different kinds of light, because wavelength and color are the same thing in light. And then this is how it describes amount of light. It's a little complicated, but basically it's a flux, which is the amount of light through a unit area. You don't need to worry too much about that, though. Just look at, like, the heights. Now, all 7 of these spectra have the same x-axis, but their y-axes are not the same. So make sure you don't make mistakes based on that. Like, the scale of their y-axis isn't the same. They're in the same units, but the scale isn't the same. The x-axis always goes from a little under 4,000 to a little over 9,000. Now, this graph at the bottom. Now, okay, I'm getting a little ahead of myself. You'll see all these little dips, and each of them has a little label, right, with these vertical lines. These are labeling the various absorption lines in the spectrum, right? For instance, like, this one says O3, so I'm pretty sure that represents, like, some kind of jump in the oxygen atom, like from the 1st to 3rd orbital, or something like that. That's basically what that means. You don't need to pay much attention to these. All you really need to pay attention to is the hydrogen alpha line. You can see hydrogen alpha right there. But, for convenience, this has this. This is a zoomed-in view of the hydrogen alpha line for the star. Right? It's part of this same graph, but it's zoomed in so you can look at the hydrogen alpha line in detail. It has, you can see, a much smaller scale for the x-axis. It goes from about 6,500 angstroms to 6,630 angstroms. And you can see the little hydrogen alpha dip right there. Also, it has changed its complicated units into a normalized flux, where basically it just chose a flux location to be 1, and then defined everything around it relative to that. So, the thing about this is these two triangles were put there so that you can kind of draw a line, a straight line between them, to kind of guess at what the line would look like if the hydrogen alpha dip was not in there. And that is how you're going to estimate the strength of the line. You draw a line, and you see how many of these boxes tall this is. So this looks like it would maybe be 2.5, 3 boxes tall. Sometimes you're going to have ones that are pretty close, and so you're going to have to look closely, because you're going to have to compare these 7 stars and how strong their hydrogen alpha lines are as part of this assignment. And sometimes they're going to have hydrogen alpha lines that are pretty close to each other, so you're going to have to look closely to see which one's stronger. Now here's an important point. When you have to classify the strength of the hydrogen alpha lines, strength only includes, the stronger a line is means it has a deeper curve. It goes down deeper from how it would go if the line wasn't there. But when I say deeper, I really mean just deeper. The width of the curve is not part of the strength. So if you see a curve like this hydrogen alpha line, and also a hydrogen alpha line like this one is stronger, right? Because you only want to look at the depth at the lowest point and count up this area. All this area on the sides you don't include. Because if you did, that would suggest that this one is stronger than this one. And if you do it like that, it is going to mess you up. So, only use the depth of the hydrogen alpha lines to determine strength. Don't think about the width. And with that, I think you are prepared to do the assignment. Go ahead and get to it, if you need to, if you haven't already done it.